हेलो एवरीवन, गुड इवनिंग टू ऑल ऑफ यू। कैसे हो आप लोग बताइए, जल्दी से बताइए मेरी वॉइस ऑडिबल है या नहीं। हेलो गाइस, सो टुडेज आवर लेक्चर इज गोइंग टू बी ऑन टू पोर्ट नेटवर्क्स। कल की क्लास नहीं हो पाई थी बिकॉज ऑफ अ टेक्निकल इशू। ओके, सो वी आर डूइंग द सेम लेक्चर टुडे। सो आई होप यू आर डूइंग वेरी वेल। जल्दी से मार्क योर अटेंडेंस। टेल मी हु हैज कम। गुड इवनिंग कोमल, गुड इवनिंग अमृता, गुड इवनिंग प्रिया, everyone good evening. So guys, today's lecture is going to be very important for your gate point of view because a direct question you will get. Okay, one or two question directly you are going to get from this particular class. Okay, apart from the network, the importance of two port network are also in case of your analogs and a different subject also. As you know, in power system we use the ABCD parameter, in analog we use the H parameter. Okay, and apart from these two parameters, the direct question will come from your network theory. So today we are going to learn the basics of parameter. We will learn how to solve the question, what are the different types of question that may come in your exam. Okay, apart from this we will see a brief introduction of symmetricity and reciprocity also. Okay, so today's lecture is going to be very important. So let's start our today's lecture. So guys, first of all, tell me, is my voice is clear? सबको voice आ रही है? Yes or no? Okay, so just start out today's lecture. As before that, we are in the last sessions we have done the transient analysis, and I told you transient are very important. Okay, so let's start out today's lecture. If you are watching me first time, this about myself. My name is Ishaan Mudgal. I have a 3+ year of experience, 5 times GATE qualified, and AMTEC gold medalist from NIT Allahabad. These are my area of expertise, and guys, follow me on a Gradeup app so that you can get a score booster series in network theory and as well as in a power electronics and power systems also. Okay, and the link is given in a description to follow me on a Gradeup app. So let's start our today's class. So first of all, the basic things you know, so I will not waste your time in those basic things. What are the basic things? A two-port network are of 6 parameters. Okay, I have shown the 5 parameter here. There is one more parameter, G parameter. Okay, so a two-port network has 6 parameters: Z, Y, ABCD, H, and ABCD dash. First of all, this is the general representation of any network. Okay, in which this is a port 1 and this is the port 2, and whichever port you give the input, that become the input port. It means never say this is an input port, never say this is an output port. Wherever you attach the input, that particular port will become the input port. Simple logic, right? Now we have this parameters. Now listen very carefully. ABCD parameters. See this parameter very carefully. In all of the other parameters, you have and actually this is also minus. This is also minus. Or just put plus here, put minus here. In all of the other parameter, you will see, let me correct myself quickly. So in all of the parameters, you can see you have a plus sign between them, but in ABCD parameter and in ABCD dash parameter, see very carefully, you have a minus sign with I2. Why? Because beta, in ABCD parameter, actually current flow outside the network. This is the actual flow of current for the ABCD parameter. Because ABCD parameter actually link the input side to a output side. Okay? If this is an input side, then this is the output side. So current must leave the network to make it an output side. That's why the actual direction of I2 in case of an ABCD parameter will be this one. But we are taking this as a general direction, so I have to put the minus sign here. Similarly, for ABCD dash, I have to put the minus sign here also. So this point you need to be very careful before starting the chapter. Okay, fine. Now ABCD parameter is actually a conditional parameter. Sorry, not ABCD, all the parameters. So this statement is very important, that two-port parameters are conditional parameters. And what is the meaning of this statement? Two-port parameter are conditional parameters. Conditional parameters. इस पर्टिकुलर स्टेटमेंट का मीनिंग क्या है बेटा? इस पर्टिकुलर स्टेटमेंट का मीनिंग ये है, द मीनिंग ऑफ दिस पर्टिकुलर स्टेटमेंट इज दैट, फॉर एग्जांपल लेट अस सपोज आई एम टेकिंग अ Z parameter. Okay, I'm just taking a Z parameter. So a Z parameter can be represented through this general equation. And beta, remember general equation of each and every parameter. You just need to remember the general equation, then you can solve the question very easily. So you can see in this general parameter Z11, Z12, Z21 and Z22. These four I need to find out. But to find out four variable, I need four equations. But here I have only two equations. Then how can I find out four variable? For this I have to use the condition. What are the different condition we use? In each of every parameter, I have to make this particular quantity 0. This 0, this 0, this 0. So in case of a Z parameter, what happen? I will put I2 equal to 0. What is the meaning of I2 equal to 0? Very important. It means port 2 is open, because when the port is open, only then the current will be 0. So in this case, I2 becomes 0. So if the I2 becomes 0, then Z11 will be V1 divided by I1 and Z21 will be V2 divided by I1. But remember very carefully that I2 is equal to 0, then this is the condition and this is the value. Now if I put I1 equal to 0, what is the meaning of this? It means port 1 is open now. It means port 1 is open. So if port 1 is open, or I can say I1 is 0, so I can put Z12 is equal to V1 divided by I2 and Z22 is equal to V2 divided by I2. This is the reason every parameter is the conditional parameter. Okay, you cannot find out the values of these parameters until you take some condition. Similarly, you can find out condition for any parameter. For example, if I talk about H parameter, what will be the condition? बताओ मुझे चैट में टाइप करके बताओ कंडीशंस कौन कौन सी होगी. If I want to find out H parameter, what will be the condition? Okay, जल्दी से टाइप करके बताओ मुझे. So first of all, you can see V2 and I1. So you can take any condition, first condition, no problem. So condition first, V2 equal to 0, or I can say port 2 short circuit. Condition 2, I1 equal to 0, or I can say port 1 open circuit. Okay, jaldi se type karo bachcho. The simple question I am asking, simple question. Then what is the condition for H parameter? These are the conditions for H parameter. Similarly, you can find the condition of Y parameter and other parameters. Okay. Now some basic information. This parameter is also known as the open circuit parameter. Why this is known as the open circuit parameter? The simple logic is that in both the cases, I1 and I2 is open, port 1 and port 2 is open, and Y parameter, sometimes called short circuit parameter, and it is also known as the admittance parameter. Similarly, it is also known as the impedance parameter. Okay. ABCD parameter is sometimes known as the T parameter, where T stands for the transmission parameter. So for the students of electrical background, you are using this parameter in your power system very extensively. H parameter is known as the hybrid parameter. Can anyone tell me what is the meaning of hybrid here? Can anyone tell me? Okay, so you can find out each and every condition from this particular general equation. So general equation are very much important to remember, very much. In each and every question, we are using the general equation, right? Next. Okay, next point. Now, symmetricity and reciprocity. So I will not go into derivation because derivation is not important right now. I will tell you the result directly. Now, what is the meaning of symmetricity or reciprocity? Now, remember our earlier classes. In earlier classes of the equivalent resistance of a diagram, I told you a network is known as the symmetrical network if you will draw a line such that on both the side of a line you will get a mirror image. For example, let me draw one simple network. Let me draw one simple network like this. This is a very simple network I am drawing, and I have to check whether this network is symmetrical or not. So to check the symmetricity, I just draw one simple line and I have to see whether there is a mirror image on both the side of the line, yes or no, right? So you can see this network is symmetrical, absolutely. Then why we are learning the symmetricity in two-port network? The only reason is that in physical life or in practical life, you are not getting the configuration properly. Okay, or you can think about, if configuration is not given, just v1, v2, i1, i2 are given, and from these particular values I need to find out whether the network is symmetrical or not. In that case, we use the two-port network. So again I will repeat myself. Hello everyone. Hello Ashok. So again I will repeat myself, guys. Why we are using an two-port parameters to find symmetricity? Because in some cases it will happen the network will not given, the configuration will not given, and if configuration is not given, how will you draw the symmetrical line? For that I have to understand the conditions in a two-port network. So if any network is a symmetrical network, then few conditions they will satisfy. What are the conditions? That in Z parameter, principal diagonal is going to be equal. In Y parameter also, the principal diagonal is going to be equal. And in ABCD parameter also, the principal diagonal is going to be equal. But in case of an H parameter, the determinant is equal to 1. A determinant you can write H11, H22 minus H21 minus H12. This is the determinant. Yes or no? बेटा आप इन इक्वेशंस को मैट्रिक्स फॉर्म में भी तो लिख सकते हो, राइट ना? इसमें तो कोई प्रॉब्लम नहीं है ना. You can write this equation matrix form very easily. How? Let's suppose I want to write ABCD parameter in a matrix form. How will I write ABCD parameter into a matrix form? I will write ABCD parameter like this. And I told you that for a general ABCD parameter, the current I2 will be in a negative form, right? So this is the ABCD parameter. Similarly, you can write every parameter into matrix form. Simple pointer. Okay, so this is the symmetricity. Or if you want to see about the ABCD dash also, this will be A dash D dash. If you want to see about the G parameter also, it will be this one. Okay, but these two will not be used that much in your exam. Next is the reciprocity. Now again, remember my class of superposition and reciprocity theorem. I told you one statement very specifically. A network which is a passive form, or you can see only one source is connected at the source side, then the whole network is a reciprocal network. And if the network is reciprocal, it will satisfy the reciprocity theorem. So remember, I gave you reciprocity theorem in my superposition theorem class. Okay, if you haven't seen that lecture, kindly see that lecture whenever you get time. So a reciprocity circuit, or you can say reciprocal circuit, is the circuit which follow the reciprocity theorem. Okay, which follow the reciprocal circuit. Reciprocal circuit, sorry, my fault, my bad. Reciprocal theorem, reciprocal circuit. Okay, so a network is known as the reciprocal if it satisfies the reciprocity theorem. And what is the reciprocity theorem? Listen very carefully. For a passive network, the ratio of output to input will be same if you change the two port of the particular network. Okay, so how will you identify a reciprocal network? If the network is given, if the configuration is given, and in that configuration all of the elements are passive element, means R, L and C, the network is reciprocal, absolutely. But if the network configuration is not given, then I have to use the two-port network. So in this case, what happened? The non-diagonal elements of Z parameter and Y parameter are equal. Okay, in ABCD parameters, see very carefully. In ABCD parameter, determinant is equal to 1. Determinant is equal to 1. Okay, and in H parameter, the non-principal diagonal element are inverse to each other, or you can say negative to each other. Okay, H12 is minus H21. Very important concept, very important. If you understand this concept now, then solving the question, the time to take to solve the question will get reduced by half. Okay, for example, if you have some symmetrical as well as reciprocal network, then you just need to find out Z11, Z12, and the others will find out automatically because you know the particular concept. If you don't know the concept, then it will be very difficult to solve the question in less amount of time. Okay, so this is going to be very important, right? Now, this is the slide for everyone is waiting, that how to solve the network. Okay, so I have divided the network two-port network question in three parts. First of all, simple network. Second is the complex network, and third, if the configuration is not given. Do you understand now what is the meaning of configuration? Configuration means how does a different elements are connected to each other, or you can say how many elements are present. This is known as the configuration. Fine. So if the network is simple, now how will you identify a network is simple? Again, simple network, complex network is totally your perspective. If you think a network is simple, use this procedure. If you think network is complex, use this procedure. Because these two procedures can be interchanged to each other also. I just write this procedure to save your time. So simply if I say simple network contain two mesh or ज़्यादा से ज़्यादा three nodes, okay? Whereas if a network contains 3 mesh, 4 mesh, it will come to a complex network. Okay. So what is the procedure to find out the two-port parameters of a simple network? First, write all the KVL and KCL equation that link both voltages and circuits. Okay. Jitni bhi KVL, KCL equation possible hai, write all of those equation. Okay. Then rearrange the equation and compare with the general equations. What are the general equations? These are the general equations. Means you have to rearrange KVL and KCL in these type of equations according to the parameter you need to find out. Okay guys. Next, for a complex network, take case 1 of the parameter and redraw the network. See beta, if a network is complex, it contains 3 to 4 meshes, then write down all the KVL equation is not possible, or you can say it will take much time to write all the KVL and KCL equation. So what I will do, I will reduce the complexity of network by taking first case. For example, if I talk about a Z parameter, so I told you case 1 is I2 equal to 0. So if you make I2 equal to 0, the network complexity will get reduced. And from that particular network, you can calculate two elements of a matrix. For example, if I talk about Z parameter, I2 is equal to 0, I can find out Z11 as well as Z21. Fine, right? Sorry, right? Now, next step, take the case 2 and again redraw the network and find out the remaining elements of a matrix, right? Now, this particular column is very important because many question has been asked and will be asked on this particular column. That this particular column is that they will not provide you the complete network. They will provide you some information, like they will give you some parameter of a network, but they will not give you the proper network configuration. They will only give you parameter of a network and then they modify the network. If they modify the network and then they will ask you some parameter. For example, simple से example आपको मैं बता देता हूँ. Simple से example बताता हूँ. I have a network whose Z parameter is this. I have a network whose Z parameter is this. Now, if I add one branch here, for example 2 ohm, now I need to find out new Z parameter. So you can see the configuration of this particular network is not given, just the information of Z parameter is given and a new branch is added. So how to solve this question? This is the step I have written here. First of all, write the given parameter into general form, okay, and write the equation for the modified network. Okay, modified network means when you modify this particular network by adding a branch, a new equations will form. So I have to write those new equations also, and then I have to rearrange the equation to find new parameters. So guys, take a screenshot for this slide because it's going to be very important. Every question we are going to solve using this particular slide, right? Now one important point I want to give you. This point will help you to solve the question very easily. This will help you to solve the question very easily. Okay, what is the important point I want to give you? So let me add a page very fast. So let me add a page and I want to give you few points and then we'll start a question. I will give you few last points and then we'll start a question. First of all, I am giving you a shortcut methods. I am giving you the shortcut methods, okay, because exam is near, you need to understand the shortcut methods. So first shortcut method is that if you have a T network, if you have a T network like this is Z1, this is Z2, this is Z3. Okay, then you can write down Z parameter directly like this. The first element will be summation of this thing, Z1 and Z2. This will be a summation of this, Z2 plus Z3, and non-principal diagonal will be equal to Z2. Okay, this is the first shortcut. If you want to find out the Z parameter for a T network, or you can say star network, this is the shortcut, and you will amazed to know that on this particular concept, 7 questions all along in ECE has been asked in the last 10 years. And if you include the EE, in EE 5 questions on this particular network has been asked in the last 12 to 13 years. And IN also, this is the same number. So this network is very, very important. So to save your time, remember this particular shortcut. If we have a T parameter, the Z parameter will be like this one. Next shortcut, if you have a pi network, okay, pi network, or I can say delta network. Now to find in a pi network, again there is a shortcut, but the shortcut is for the Y parameter. So listen very carefully. Whenever you have a delta network or a pi network, convert each impedance into an admittance form. This will be Y1 ohm, this will be Y2 ohm, this will be Y3 ohm. And after that only you can apply the shortcut. Okay, so remember, whenever you got a delta network or you can say pi network, convert each impedance into admittance form and then apply the shortcut. Shortcut is Y1 plus Y2, here Y1 plus Y3, here minus Y2 and minus Y2. Okay, means Y1 plus Y2 is the first element, Y2 plus Y3 is the second element of a diagonal, and then this is a non-principal diagonal, it will be minus Y2 and minus Y2. Okay, good Komal. Now next point, Y parameter is the inverse of Z. Y parameter is the inverse of Z. Now think about it. In the question, they are asking you to find out Z parameter of this network. For example, in some question, they are asking you to find out Z parameter of above question. So what you will do? You will find out Y parameter using a shortcut method. Yes or no? And then you can find out the inverse. And finding out the inverse of 2 by 2 matrix is very, very easy. Finding out the inverse of 2 by 2 matrix is very, very easy, right? So whenever you get the delta network, find out Y parameter and then convert into Z, because they are inversely interconnected. Similarly, ABCD parameter is the inverse of ABCD dash. Okay, and next H parameter, or you can say G parameter, is inverse of G. This is actually ABCD dash. Okay, so remember this particular relation. This is going to be very, very helpful for your exam, right? Now few short points also. For Z parameter, write only KVL equation. For Z parameter, write only KVL equations. For example, some network is given and you need to find out the Z parameter. In that case, you need to write only KVL equation and you will find out the Z parameter easily. No need to write down the KCL equation. For Y parameter, write only KCL equation. Again, for a Y parameter, if you find out only the KCL equations, then you can find out the Y parameter easily. Okay, so remember these points. This slide is going to be very, very helpful, and I have already told you on this, and on this many questions has been asked. Just see your previous year question. Fine, guys. Okay, so now we will go to a questions and we will solve the question for the next 30 to 40 minutes. Right, so this is the first question. In this, I need to find out the Z parameter. So before starting a question, I want to give quick information about this structure. This structure is known as the lattice network. This structure is known as the lattice network. Okay, now understand one point very, very carefully. In a two-port network, if this is shown like this, it doesn't mean it is open. Remember, it does not mean it is open. Okay, this is a general representation of a two-port network. So a two-port network is given like this, and I need to find out the Z parameter. Now tell me, is this a simple network or a complex network? Tell me, is this a simple network or a complex network? The answer is this is a complex network. Why this is a complex network? Because if you solve it using the simple network, you have to divide. You have to divide the current at many nodes. And you can see it has 1, 2, 3, 4 nodes. And I told you, whenever you have 2 mesh or 3 nodes, then the network will be simple. Otherwise, the network will be complex. Okay. Now, next question I want to ask you. Tell me, is this a symmetrical network or not? जल्दी से बच्चों, मुझे रिप्लाई चाहिए चैट में सबका. आपका रेस्पॉन्स ठंडा नहीं होना चाहिए. ओके, सो टेल मी, इज दिस अ सिमेट्रिकल एंड रेसिप्रोकल नेटवर्क? यस और नो? everyone should reply. Symmetrical and reciprocal network है या नहीं? The answer is yes. This network is symmetrical network. Why this network is a symmetrical network? Because you can see, if I draw one particular line, horizontal or a vertical, you will get a mirror image on both the side of a line. And this network is also reciprocal network. Why this network is a reciprocal network? Because this is a passive network. You can see now, only impedance are connect, or you can say passive load are connect. So this is a passive network. So if you know this is a reciprocal network, then you already know that Z11 is equal to Z22 and Z12 is equal to Z21. This you already know, yes or no? It means I need to find out two components only, two elements only, then I can find out the whole Z parameter. Got my point? So right now I am taking it as a complex network and I will find out only Z11 and Z12. Okay. Now see very carefully, whichever parameter you need to find out, first write down the general equation of that particular parameter. So general equation of Z parameter is this one. General equation of Z parameter is equal to this one. Now see very carefully guys. If I make I2 equal to 0, I can find out the Z21 and Z11. इसका मतलब क्या है? मैं ये दोनों find कर लूंगा and the rest will be equal to this. So no need to take the second case. But if you don't know this particular concept, then you have to go through the whole subjective method and you have to apply both the cases, right? So what I will do here, I will only use one case. So here I am applying put I2 equal to 0. Now put I2 equal to 0 means I have to make the port 2 open. So now I am again drawing the circuit. Okay. Now port 2 open means it will be open like this. This is the meaning of port 2 open. Here I have one impedance. Like this. And this is Z1, this is Z2, this is Z2, this is Z1. This is the I1 plus minus V1. Now bachcho, see very carefully. It is open now. If it is open, I2 is 0, but there will be a voltage absolutely. Across the open circuit, we will have some voltage, but the current will be 0. Fine. Now see very carefully, when you open circuit this terminal, now you can see Z1 and Z2 comes in a series. Yes or no? Similarly, you can see our Z2 and Z1 is coming in a series. Yes or no guys? Jaldi se batao, yes or no? When you open circuit this terminal, whatever be the current flow, it goes to this particular path. Similarly, a current will go to this particular path. Yes or no? Right? Or you can also redraw the circuit once again. How can you redraw the circuit? You can redraw the circuit in this form also to understand this particular concept. You redraw the circuit in this form also to understand this concept perfectly. See, this is plus minus V1. Here the I1 goes. Now when I1 goes, it intersect Z1 and Z2. So here it is Z2, here it is Z1. Okay. Now Z1 is in series with another Z2. This will be Z2, this will be Z1. This is also representation of this particular network. Fine, yes or no? So you can use either particular network, this one or this one. So this is plus minus V2. Plus is along the Z2. This is plus minus V2. Fine. So you can use any particular network. Now see very carefully. These two branches have equal impedance. So it become I1 by 2. This is also become I1 by 2 because the current will flow equally in both the branches because of the same impedance. Now I want to find out what? I want to find out Z11, which is the ratio of V1 divided by I1. So you can see here, I can find out V1 like how this is the series branch and across this I have a voltage V1. So I can write V1 is equal to I1 by 2 bracket Z2 plus Z1. Right? So Z11 is equal to V1 divided by I1 is equal to Z1 plus Z2 divided by 2. This comes out to be Z11. Yes or no? Simple. Now you need to find out the next ratio. The next ratio is what? The next ratio is between the V2 and I1. The next ratio is between the V2 and I1. So let's find out the ratio between V2 and I1. Let me check the polarity first. Let me check the polarity first. It will be plus and minus. Okay, just correct the polarity. It will be plus and minus. Okay, आप लोग बताओ पोलैरिटी कौन सा लगाऊं, चेक करके बताओ. आपको भी देखो मैं, you can apply the correct polarity or not. Let me see if you can apply the correct polarity or not. How will you apply the polarity? See very carefully. You can see I1 is going here, okay, and it is Z2, it is Z1. So you can see I1 is going here, it is Z1, it is Z2. Now Z1 one terminal is connected to positive polarity. Z1 one terminal is connected to positive polarity like this. Okay, polarity mark karna seekh lo. It's going to be very important in every subject of your electrical and electronics. Now let's see. Mark. Now I will apply the KVL here. So apply the KVL. So I1 is entering here, it will be plus minus. This is entering here, it will be plus minus. So when you apply the KVL, how will you apply KVL? Minus I1 by 2 multiply by Z1 minus V2 plus I1 by 2 multiply by Z2 equal to 0. Simple KVL लगाया है. I hope you don't have any doubt in case of a KVL. So from here I can write V2 divided by I1 is equal to Z2 minus Z1 by 2. Just rearrange. It becomes Z21 is equal to Z2 minus Z1 by 2. This comes out to be next element of a Z parameter. Okay, and you know, because of a symmetricity, Z22 is equal to Z11. Because of a reciprocal, Z12 is equal to Z21. So simple. Just finding out two elements, you have find out all the four elements. Otherwise, if you don't know the concept of symmetricity or the reciprocity, then you have to take the second case also. Okay. So any doubt in this question? Anyone? बच्चों कोई भी doubt हो, freely you can ask. Okay. There is no foundation. You can now ask any doubt. Fine. Complete. Good. Okay. Now next question. Next question. Very beautiful question. Very beautiful question. In this again I need to find out the Z parameters. Okay. Now tell me a few points about this particular question. Is this a symmetrical? Yes or no? बताओ क्या ये नेटवर्क सिमेट्रिकल या फिर रेसिप्रोकल है? दोनों के केस में बताओ. Is this network a symmetrical and reciprocal? Yes or no? So first of all, when you draw the particular line, you can say a horizontal line or a vertical line. You will see the network is not divided into a mirror image. So the network is not symmetrical. Remember, the network is not symmetrical. Is this network a reciprocal network? A network is only a reciprocal network if it does not contain any source inside it. And you can see I have an independent sources inside it. So this is not a reciprocal network. If it is not a symmetrical, not a reciprocal, then eventually I need to find out all the parameters. Okay. So again, this is a complex network. Simple. Complex दिख रहा है ना आपको ये? Because it has a dependent source and much more. So this is a complex network, no doubt. I need to find out each parameter. So again, for the Z parameter, I will first write down the general equation. See, if during the practice you will write the general equations ना, you will remember the equation very easily. ओके अगर आप प्रैक्टिस के टाइम जर्नल इक्वेशंस को लिखकर प्रैक्टिस करोगे ना तो बहुत जल्दी आप लोग इक्वेशंस को रिवाइज कर लोगे. एंड बच्चों ओनली 2 people आर रिप्लाइंग बट आई वांट ईच वन ऑफ यू टू रिप्लाई. ओके जब तक आप रिप्लाई नहीं करोगे तो मुझे कैसे पता चलेगा आपको समझ में आ रहा है नहीं आ रहा. ओके बट गुड कोमल एंड गुड उपेंद्र, यू आर रिप्लाइंग वेरी वेल बच्चा. सो फर्स्ट ऑफ ऑल आई विल अप्लाई द केस 1. I will apply the case 1. And one more information, I will upload the PDF of this class on a Telegram channel. So you join our Telegram channel also. Fine. So case 1, I will put I2 equal to 0. So I2 equal to 0 means I am making a port 2 open. So for I2 equal to 0, if you redraw the diagram, it becomes 0.3 times of V2. Now, when I2 is 0, this is the dependent source whose value depends on I2. So it becomes 0, but it is a current source. So it will become open. Yes or no? It will become open now because it is a current source. Right? Next, here I have a 4 ohm. Here I have a 10 ohm. Fine. Here I have a 10 ohm. And the port 2 is open. So the open circuit will be represented like this. This is plus minus V2. This is plus minus V1 and here the I1 is flowing. Okay, so what I need to find out? I need to find out few ratios. I need to find out V1 divided by I1. I need to find out V2 divided by I1. So let's see. I1 is flowing through here. This is also going to be I1. This is open. So here the current will be I1 also. Plus minus plus minus. Now see very carefully. What is the voltage? Voltage is equal to across 10 ohm. So V2 will be how much? 10 multiplied by I1. Now I know what is Z21. Z21 is the V2 divided by I1. So Z21 comes out to be 10. Simply, कितना simple था? Z21 comes out to be 10. Only basics. So I am marking this equation 1. Now I need to find out a ratio of V1 and I1 also. So what can I do? The only thing I can do is to apply the KVL here. The only thing I can do in this question is to apply the KVL. So apply it. So बेटा apply कर दो इसको बिना कुछ सोचे. So it will be minus V1 plus 0.3 V2 plus 4 times of I1 plus 10 times of I1 equal to 0. Now here you will see V1 is equal to 14 times of I1 plus 0.3 times of V2. I need a ratio between V1 and I1, but ये V2 तो problem क्रिएट कर रहा है. इसका क्या करें? I know that equation 1 V2 depends on I1, तो use the equation 1. If you use the equation 1, it becomes 3 times of I1. Yes or no? So finally Z11, which is V1 divided by I1, comes out to be 17. Yes or no? So 2 elements we have find out till now. We have find out Z11 which is 17 and Z21 which is 10. Okay? Okay, yes or no? Now next case 2 we will apply. Now we will apply the case 2. नहीं कोमल बेटा Z11 is 14. See very carefully कोमल बेटा. नहीं Z11 is 17 sorry and Z21 is 10. Why Z21 is 10? Because you know Z21 is the ratio of V2 and I1. So when you see the voltage is directly across this 10 ohm. So V2 divided by I1 is equal to 10 ohm. Right? Now case 2. In a case 2 of a Z transform, I have to put I1 equal to 0. So now I have to make the I1 or port 1 open circuit. So if you make the port 1 open circuit, the equations will be like this. Now you can see this current source will come in picture. This current source will come in picture because we didn't make the I2 0. So this particular current source will come in picture like this. Okay, what is the magnitude of voltage source? Plus minus 0.3 V2. This is 4 ohm and this is 1 ohm. This is 4 ohm, this is 1 ohm and it is I2 plus minus V2. Okay, I2 plus minus V2 and this is plus minus V1. Okay, now again we will do the question very simply. So see very carefully guys. 0.2 I2 is going there. Okay, this is 0.2 I2, you can see, but it is an open circuit, so whole 0.2 I2 will go there, will reach here, yes or no? The 0.2 I2 will reach here, or from this particular port the I2 will leave. So how much current will enter here? Apply the KCL. 0.8 I2 will enter here, yes or no? Let me remove this one. Yeah, 0.8 I2 will enter here, right? So if 0.8 I2 will enter here, so how much current will leave here? 0.2 I2, and finally this current is going in this particular branch. So I did only the current distribution. करंट डिस्ट्रीब्यूशन करा है, समझ में आया करंट डिस्ट्रीब्यूशन कैसे करा है? देख लो फिर से. दिस इज अ करंट सोर्स, इट इज अ 0.2 I2, बट ये यहां पर फ्लो नहीं करेगा क्योंकि ओपन है. सो होल ऑफ द करंट विल फ्लो टू द पोर्ट 2 साइड, but here you can see at this particular node, here I have to send I2 because whatever the port throws the current, it consumes the same current. So apply the KCL, it will be 0.8 I2. Fine. Now you can see I need to find out two particular ratios, Z22 and Z12. So see here very carefully. You can see V2 is the voltage across 1 ohm. Yes or no? So V2 is equal to 0.8 I2 multiplied by 1. So V2 divided by I2 become what? 0.8, and you can write Z22 is a 0.8. Very simple. Z22 is find out. Now next ratio that I want to find out is the ratio between V1 and I2. So for finding out a ratio between V1 and I2, I need to apply the KVL. Now see here, in which loop I should apply the KVL. Very important. I told you in a starting class also, if a loop contain a current source, then you cannot apply the KVL. Okay. So see here, I will apply the KVL in the outer loop. I will apply the KVL in the outer loop. Why? Because if you apply the KVL in inner loop, this particular current source is present, and I cannot apply the KVL if the current source is present. Okay. आपको मैंने बहुत अच्छे से कॉन्सेप्ट बताया था in starting classes, right? So apply the KVL. So if you apply the KVL, it become minus V1 plus 0.3 times of V2, and you can see the direction of current is opposite now, or you can see polarity is plus minus. So here it will be minus 4 times of 0.2 I2. Here you can see plus 0.8 times of I2 equal to 0. So V1 comes out to be, you can see, minus 4 into 0.8. They are cancelled out. 0.3 times of V2. This is the V1. Now again V2 मुझे प्रॉब्लम क्रिएट कर रहा है क्योंकि मुझे तो I2 की टर्म्स में चाहिए ना, तो मैं ये वाली इक्वेशन पुट कर सकता हूं, राइट? सो V1 is equal to 0.3 times of 0.8 I2, or you can see Z12 is equal to V1 divided by I2 equal to 0.24. So finally it comes out to be 0.24 and it comes out to be 0.8. Simple. Okay. So if you are getting this type of a network and you think that this is a very big network, आपको लगे कि इतना बड़ा नेटवर्क आ गया, इसमें बहुत टाइम लगेगा, ऐसा नहीं है. कॉन्सेप्चुअली जाओगे ना तो आप देखोगे नेटवर्क कितना सिंपल हो जाएगा. हमने करा ही क्या है, हमने जस्ट पोर्ट 1 को ओपन करा है, एंड आफ्टर दैट जस्ट वी अप्लाई द KVL, नथिंग एल्स. Again, port 1 को यहाँ open किया, apply the KVL, nothing else. So only 2 or 3 equations are required, and this much level is very favorite level for a GATE exam. Okay, understood everyone? Fine. Now solve the next question. Now this question, in this question, I need to find out the Y parameter of the network. Okay, and here it is I0 na, just replace I0 with I1. Just replace I0 with I1. And guys, for your information, tomorrow is the class I will take again for the 2-port network. So we have a 2 classes left in this network session, and both of the classes will be on the 2-port network only, because this is one of the most scoring and important concept. That's why I have to take 3 classes on this concept. Okay, and the timing will be 9:30, because on our other channel, if you are following our other channel, which is the Impulse, which is the Gradeup Impulse ECE. It is a special channel we have created only for you guys. So if you are following our this channel also, there is a class going on of Rakesh sir from 8 to 9 and it will take some time for him to end the session. That's why I shifted the class on 9:30. So remember, आप इस क्लास को पहले अटेंड करो फिर मेरी क्लास में आना, राइट? बिकॉज राकेश सर कंट्रोल सिस्टम करा रहे हैं और आपको बहुत मजा आएगा उसमें. अगर आप कर रहे हो तो आपको और भी मजा आ रहा होगा बिकॉज उनकी काफी क्लासेस वहां पे हो चुकी है. And again, for the information for you, for an electrical guys, from the 30th November, which means next Monday, I am going to take the power electronic class there also. Okay, again a revision session type. I will take a power electronic class from 2:30 p.m. It means in the evening, sorry, in the afternoon 2:30 p.m. I will take class. So जल्दी से मुझे ये बताओ कौन कौन इलेक्ट्रिकल स्टूडेंट्स हैं यहाँ पर. अभी कौन कौन से इलेक्ट्रिकल स्टूडेंट्स मेरी वीडियो देख रहे हैं जल्दी से, एंड आई वांट रिप्लाई फ्रॉम ईच वन ऑफ यू. So in this network I need to find out the y parameter. Okay, Komal has given the answer. So let me write the particular parameter equation. So what is the general parameter equation? That I1 I2 is equal to y11 v1 plus y12 v2 y21 I1 sorry y21 v1 plus y22 v2. ओके, एंड बच्चों रिप्लाई किया करो क्वेश्चंस जो मैं पूछता हूं आप लोगों से. ओके, सो पेंटर इज फ्रॉम इलेक्ट्रिकल, करेक्ट. ओके, सो इलेक्ट्रिकल स्टूडेंट्स आपके लिए बहुत अच्छी अपॉर्चुनिटी है. आप कम से कम टाइम में पावर इलेक्ट्रॉनिक्स रिवाइज कर लोगे. वन ऑफ द मोस्ट इंपॉर्टेंट सब्जेक्ट है जो मैं 30th नवंबर से लेने वाला हूं ऑन आवर इम्पल्स चैनल which is specially created for you. Okay, so see very carefully. Now I need to find out the equations of I1 and I2. Now tell me, is this a simple network or a complex network? First of all, this is a simple network. This is a simple network. Second, it is not symmetrical. As well as third, it is not reciprocal. It is not reciprocal. Okay, वरुण पांडे, आपको क्या रिपीट करना है? कैन यू स्पेसिफाई व्हाट यू वांट टू रिपीट? रेसिप्रोकल. ओके, तो ना ही ये सिमेट्रिकल है ना ही ये रेसिप्रोकल है. ओके, नाउ सी वेरी केयरफुली. आप देखो आई नॉट मेरा यहां फ्लो कर रहा है, नो प्रॉब्लम. आई नॉट मेरा यहां फ्लो कर रहा है, इट इज अ शॉर्ट सर्किट पाथ. सो होल ऑफ द आई नॉट विल गो टू दिस पार्ट. यस और नो? होल ऑफ द आई नॉट विल गो टू दिस पार्ट एंड हियर यू कैन सी आई नॉट विल कमिंग आउट, राइट? Now you can see from this branch to this branch I have only 2 I naught and I2. 2 I1 actually, it is 2 I1, it is I1, it is I1. Okay, so you can see both of the current will be same. Both of the current will be same. Why both current will be same? Because in a particular branch only one current can flow, but better direction will be opposite. Okay, so the first equation will be I2 will be negative of 2 I1. I2 will be negative of 2I1. This is the first equation. I2 will be negative of 2I1. This is the first equation. Fine. Now, second equation where I can find out. I can find out the KVL here. If you apply the KVL here, you will see minus V1 is equal to I1 multiplied by 1. Or you can write I1 is equal to minus V1. This is the second equation. Now see beta very carefully. बहुत ही ब्यूटीफुल कॉन्सेप्ट मैं आपको यहाँ पर दिखाने वाला हूँ. ध्यान से देखो इस ब्यूटीफुल कॉन्सेप्ट को. गुड इवनिंग शेख. सो ध्यान से देखो इस ब्यूटीफुल कॉन्सेप्ट को. I1 को मैंने क्या बोला? इट इज माइनस V1, बट आई कैन ऑल्सो राइट डाउन दिस इक्वेशन लाइक दिस, माइनस V1 प्लस 0 टाइम्स ऑफ V2. Yes or no? Whatever you will multiply by V2, it will be 0, right? This is the first equation. Now second here, I2 is minus 2 times of I1. So what can I do? I can put the I1 into this equation. Why? Because I need equation in this form. Remember, for the y parameter, I need equation in this form. So minus 2 times of minus V1 plus 0 times of V2. So I2 comes out to be 2 times of V1 plus 0 times of V2. This is the second equation. Now compare these two equations with these two equations. You will see y11 is minus 1. Minus 1. Y12 will be 0. Y21 is equal to 2 and Y22 is equal to 0. Simple question. Yes or no? Right? कोमल बेटा हाफ कहां से आ रहा है आप मुझे बताओ. 1/2 कहां से आ रहा है? क्या मैंने कोई मिस्टेक करी है? मेरी कैलकुलेशन में चेक कर लेना बच्चों, कोई मिस्टेक हो तो बेहिचक मुझे बता देना. If I have done any mistake in calculation, you can tell me freely. And one more point, this is the question asked in a sample paper of IIT. See, before GATE exam, IIT sometime released the sample paper. Okay, so this has been this question has been released earlier years in a sample paper for IIT. Okay, right. Next question. अब इस क्वेश्चन को सॉल्व करते हैं. नाउ इन दिस क्वेश्चन आई हैव आल्सो रिप्रेजेंट द इंडक्टर आल्सो, तो थोड़ा सा एसी का फ्लेवर भी आपके पास आ जाएगा. ओके ओके, एक बहुत ही इंपॉर्टेंट पॉइंट है, उसको मैं आपको बताना चाहता हूं. वन वेरी इंपॉर्टेंट पॉइंट, एंड यू विल नॉट फाइंड दीज पॉइंट्स इन एनी ऑफ द बुक. ओके, दिस पॉइंट विल जस्ट कम आफ्टर द प्रैक्टिस, सो लिसन दिस पॉइंट वेरी केयरफुली. if non independent if independent variables or independent quantities, if independent quantities, if independent, अरे मेरे स्पेलिंग का क्या हो गया यार, if independent quantities are linked to each other, if independent quantities are linked to each other, then parameter will be infinite. Very important conclusion. Okay, Abhishek is saying one thing. Sir, isn't V1 is equal to I1R? So बेटा सी वेरी केयरफुल ना, आप इस वाले की बात करो ना मुझे, तो देखो अभिषेक वेरी केयरफुली, यू कैन ऑल्सो राइट V1 इज इक्वल, देखो हम यहाँ पर KVL लगा रहे हैं, आप देखो ध्यान से देखो, मैं यहाँ पर इस पर्टिकुलर लूप में KVL लगा रहा हूँ, ठीक है. एंड यू कैन सी व्हेन यू मार्क द पोलैरिटी इट विल बी प्लस एंड माइनस, सो व्हेन यू मार्क द पोलैरिटी, अच्छा मैंने यहाँ मिस्टेक कर दी, करेक्ट, माय फॉल्ट, करेक्ट, थैंक्स अभिषेक. ऐसे बच्चों ऐसे देखा करो, थैंक्स अभिषेक. देखो अगर आप यहाँ पे आप पे केवीएल भी लगाओ तो क्या आएगा, -v1 प्लस i1 मल्टीप्लाई बाय 1 इक्वल टू 0. सो v1 कम्स आउट टू बी i1, करेक्ट अभिषेक, एब्सोल्युटली. इट कम्स आउट टू बी 0 टाइम्स ऑफ v2 प्लस v1. ओके, सो हियर आल्सो इट विल बी प्लस v1. ओके, इट विल बी प्लस v1, इट विल बी -2, सो इट विल बी +1, it will be -2. okay, everything is correct now, correct अभिषेक. so guys ध्यान रखा करो, मिस्टेक फाइंड करना बहुत जरूरी है, सही बात. so इस पर्टिकुलर लाइन का मीनिंग क्या है, तो देखो आपको एक एग्जांपल से इस लाइन का मीनिंग बताता हूं मैं. मान लो कि z पैरामीटर आपको फाइंड करने हैं, ठीक है. यू नीड टू फाइंड आउट अ z पैरामीटर. ओके, सो v1 v2 is equal to z11 i1 plus z12 i2 is equal to z21 i1 plus z22 i2. ओके, तो ध्यान से देखो ये जो पैरामीटर्स होते हैं ना, these are the dependent parameter. Why they are the dependent parameter? Because they are depending on the values of i1 and i2, whereas i1 and i2 are the independent parameters. Independent parameters means you can put any value of i1 and i2, but generally we put these value equal to 0. Now if i1 is if i1 is somehow related to i2, or I can say from some diagram I can write i1 is k times of i2. i1 is k times of i2. K times of i2 means you have some relation between the independent quantities. Then what happen? The z parameter will be infinite. So no need to solve further. You can directly write that z parameter will be infinite. ऐसा क्यों होगा, दिमाग लगा के सोचो. अगर मैंने केस 1 ले लिया, just use your mind. If I take the case 1, what is the case 1? That i2 is equal to 0. अगर मैंने केस 1 ले लिया कि i2 0 होगा, so using this equation eventually i1 किसके इक्वल हो जाएगा, k multiply by 0 0. Now what is z11? Z11 is V1 divided by I1. So it will be V1 divided by 0. It comes out to be infinite. Very important concept. इसके ऊपर कभी भी क्वेश्चन आ सकता है. सो लेट अस सपोज आपको बहुत ही कॉम्प्लेक्स सा नेटवर्क दे दिया, दे आर प्रोवाइडिंग यू वेरी कॉम्प्लेक्स नेटवर्क, but in that network you find these type of relation between the independent quantities. Then without solving any other thing, just put the parameter equal to infinite. Got my point? Independent quantities के बीच में कभी भी relation नहीं आना चाहिए, right? Okay, this question now. Now in this question I need to find out the h parameter. So for the h parameter I need to write down the equation of h parameter first. So let's see what is the equation of h parameter. V1 I2 is equal to h11 I1 plus h12 V2 h21 I1 plus h22 V2, right? Now you need to find out two parameters, h11 and h12. So it is actually a MSQ type of question. It is actually a MSQ type of question, so more than one answer may be correct. So let's see what is given. So see very carefully. I1 is going there. It is a simple network. First of all, it is a simple network. Okay, no doubt. It is a simple network. Okay. Next point, it is not symmetrical and not reciprocal. Is this a network reciprocal? Yes, the network is reciprocal. Why the network is reciprocal? Because the network does not contain a dependent or independent source inside it. So this will be a reciprocal network. Okay. So let's see. This is the I1 flowing. Here you can see I2 is flowing. So how much current will flow here? I1 plus I2 will flow here. I1 plus I2 will flow here. Then I can find out the equations now. Write one equation here. Write one equation here. So if I apply the KVL, if you apply the KVL, you will see V1 is equal to 2 times of I1 plus J5 times of I1 plus I2. Or if you rearrange the equation, it becomes 2 plus J5 times of I1 plus J5 times of I2. Now if I apply the second KVL equation, you can see V2 is equal to J5 times of I1 plus I2, or if I open the bracket, it becomes J5 times of I1 plus J5 times of I2. So this is the equation second. Okay, got two equations. What I need equation in this form. I need equation in this form. So let's see. Now you have to just you need to just find out equation this form. How can you find out? See very carefully. The second equation between I2, I1, V2. But this equation between V2, I1 and I2. So I can rearrange this second equation to find out. I can rearrange this particular equation to change in this one. So how will you rearrange it? The I2 become equal to what? Minus J5 times of J5 I1 plus 1 divided by J5 times of I2. Sorry, V2. Yes or no? Just rearrange करना है. Mathematics में अब बस आपको rearrange करना है. So it become I2 is equal to minus I1 प्लस माइनस J डिवाइड बाय 5 V2. तो आप देखो क्या आ गया, H21 कितना आ गया -1, H22 मेरे पास कितना आ गया -J5. तो आई विल राइट हियर H21 कितना आ गया -1, H22 is -J divided by 5. Now I can put this equation of I2 in this equation. Why? Because then the equation become V1 I1 and I2 that I want in this particular method. Okay, so see very carefully, just rearrangement you have to do. So V1 is equal to 2 plus J5 times of I1 plus J5 times of I2. What is I2? See very carefully. I2 is minus I1 minus J by 5 V2. Okay, so just you need to rearrange the equation. It become 2 plus J5 minus J5 I1, and here you will see it will be minus J square V2. So it becomes 2 times of I1 plus V2. So you can see H11 is equal to 2, H12 is equal to 1. H12 is equal to 1. तो हमसे क्वेश्चन में क्या पूछा है? क्वेश्चन में पूछा है H11 and H12. So H11 2 and 1. So 2, this is the right answer, and B, this is the right answer. Okay, so MSQ type of question can be come in this form also, and you know MSQ is the latest pattern introduced by IIT. Okay, now take this question in homework. Now take this question in homework and give the answer in a comment section. Okay, and जो भी आंसर देगा उसका नाम मैं नेक्स्ट क्लास में डिस्प्ले करूंगा. तो give the answer in a comment section for this particular question. Okay, ABCD जो आंसर देगा उसका नाम मैं नेक्स्ट क्लास में अपनी स्लाइड में ऐड करके डिस्प्ले करूंगा. ओके, सो ABCD जिसका भी सही आंसर होगा, बट एवरीवन शुड ट्राई एंड गिव द आंसर इन द कमेंट सेक्शन. ओके, एंड इन द नेक्स्ट क्लास वी विल डू सम मोर क्वेश्चंस. सो कल की क्लास में हम क्या करने वाले हैं, आपको दो होमवर्क दे देता हूं. एक तो होमवर्क ये रहा और एक होमवर्क ये वाला क्वेश्चन. टेक द स्क्रीनशॉट. So what we are going to do in tomorrow class? So in tomorrow's class we are going to understand more questions and basically the type 3 question. What is the type 3 question? In which the configuration is not given. उस क्वेश्चन में कॉन्फ़िगरेशन गिवन नहीं होगा. अभी तक जितने क्वेश्चन करे या तो वो सिंपल नेटवर्क है या तो वो कॉम्प्लेक्स नेटवर्क है, बट थर्ड टाइप के क्वेश्चन अभी तक हमने नहीं करे. So in tomorrow's class we are going to see the third type of questions. Okay, but beta I want reply from each one of you, so everyone should reply it. कंजूसी मत क्या करो रिप्लाई करने में. Okay, and subscribe this channel if you haven't subscribed this, and take care. If you have any doubt you can ask right now. Otherwise we will end this session, and tomorrow we are going to meet on the same time 9:30. Remember it. So just after a session from your Impulse channel, come to this particular channel and follow me here. So bye bye guys, take care. Hope you enjoyed the lecture. Good night, sweet dreams.